Today we're going to start talking about our law of sines. We've just finished up our right triangle trig and our Pythagorean's theorem and similar triangles. What we need to know about law of sines is used when we do not have a right triangle. It can be used on a right triangle, but we would rather use the other trig ratios. So we are going to deal with our law of sines today and non-right triangles. The first thing we're going to want to record is what we're looking at here, which is our formula for the law of sines. You can see this is written here. It is written as a three-term proportion. We can see A over sine A is equal to B over sine B, which is equal to C over sine C. What you need to understand on this is we're not trying to get a three terms. We're just saying any combination of these two. Sine A could be set equal to sine B, or A could be set equal to C, or B could be set equal to C. Any combination of these three terms can be used. Now, the one we're going to use is always going to be one where we have a combination of an angle and its opposite side. That's the thing we've got to recognize on this. All right, hopefully I bought you some time as you wrote this formula down, but here's when we use this formula. We use this formula when we have either angle, side, angle, side, angle. So essentially, if you have two angles, you will use this formula. And then we also can use it on side, angle. We cannot use this if the only angle we have is between our two known sides. So we can use this for angle, side, angle, and side, angle. So I told you we can use it for those points. And this actually, the picture we're looking at here, hopefully you have that down. Picture that we have here is technically angle, side, angle. So if we have angle, side, angle, I also told you we have to have an angle and its opposite side. Well, here's an angle we have. We don't have its opposite side. Here's another angle we have. We do not have its opposite side. But the thing is, we've got to remember about triangles. If we have two of the angles, then we have all three, because the sum of the interior angles is going to be 180. So we know that if we take these two angles away from 180, that this missing angle is 35 degrees. So now we have a side and its opposite angle. When we set up a proportion, we have to use these two. You have to have that type of combination. So we're going to take the side 12 over sine of the opposite angle, which in this case is 35. Now we can set up the proportion to either one, the 54 or the 91, but the 54 is not going to help us because we are looking for side DF. DF is this side over here. So the angle that is opposite of DF is 91. So we're going to have to set up that proportion. So our second side proportion will be DF divided by sine of 91. Sine of 91. Now I want you to remember all of these are numbers. Sine of 35 is a number, sine of 91 is a number. But to keep these accurate, what we're going to do is we're going to leave these in the trig form. That will help us stay accurate a little longer. So we're going to cross multiply these two, leaving us with 12 sine 91 equals side DF times sine 35. So we are solving for DF, so we need to divide by everything that is not DF. That in this case is sine of 35. So we divide by sine 35. And then this is going straight into our calculator. I would suggest using the alpha y equals button. That is the fraction setup combo. That's the F1. But when we set this up, we can type in our data just like it reads. Make sure again that you are in degrees, not radians. That would be under mode. Go in under mode, make sure that you are in degrees, not radians. When I do this, what I learn is the side DF is equal to, it's actually approximately, because we're going to be doing some rounding here, DF is approximately 20.92. And that makes sense because my largest angle is 91, so this side is larger than the other one. So we know we have a pretty relevant, decent answer here. So these are the examples in your Delta Math. I've drawn my own triangles here kind of ahead of time. On these, you're going to have to create your own triangle. Mine is pretty well to scale, but we'll see how well this works. I'm going to go ahead and label these. Notice it's triangle JKL. Well, I'm going to label my angles. J is about 90 degrees, just under. L is about 74. Whoops. L is about the 74 degree, and I could be numbering these as well, which means K has to be the third side. It is important where we put our sides and our angles because J has to be opposite of angle J. So if angle J is right here, side J is opposite of that. So side J does have a measurement of 7.2. So that's what our figure looks like. So in this particular example, we have to use J because the J combination is the only one that we have two sides and two angles for. So we are going to set side J over sine of angle J equal to. Now we're going to set this equal to angle L because we're looking for side L. So we don't know what side L is. We'll use the letter L, and this will be divided by sine of angle L, which has a measurement of 74. Once we've set this up, now it's just a matter of solving a proportion. We're going to cross multiply this, giving us 7.2 sine 74 equals L times sine 89. So we will now divide both sides by sine 89 in order to get our L by itself. And as I'm doing this, I want to be thinking about how big this side is going to be. Well, 89 is the largest angle, and it is 7.2. L is the second largest, so it's going to have to be lower than 7.2. Not too far off, though. So as I'm putting this into my calculator, because this, whatever comes out of this is L, so 7.2, excuse me, sine 74, all divided by sine 89. Now, please don't come in here and try to cancel those, because sine 89, sines don't cancel because they're actually part of a bigger thing. This says round to the nearest tenths of a centimeter, so I get 6.92, so it stays at 6.9. All right, I'm going to pick up the pace just a little bit on this one. So what we have here is our angles. Again, this doesn't have to be perfectly to scale, but I'd like to try to make it that way. So I'm going to call my smallest angle Q and my second smallest angle S. So Q is 22 degrees, S is 23 degrees. One thing we should notice on this as well, so the only thing left is R, and we actually know side R, which is 1.5. One thing we should notice, Q and S, this is almost an isosceles triangle, almost. So the sides opposite of those two angles should be close in value. And we are looking for side S. Well, angle S is here, so side S is right there. So we only have one combinations of angles and sides, and that's our friends, the R's here. So we have to use our R's. We do know what angle R is. Remember, we have two of the three sides of a triangle. So we're going to subtract those two sides. And what we learn is this is 135 degrees. So here's the proportion we're going to set up. Side R over sine of angle R, which is 135, is equal to, we want side S, so we're going to choose S over sine 23. Proportions are good friends from middle school. We're going to solve our proportion. Sine times S, S times sine 135. And as usual, we divide here. We divide by sine 135 in order to free up our S. And S equals, and again, I keep going to the fraction mode. I don't like to try to deal with all this stuff and remember where the parentheses are supposed to go. So I set up that fraction mode and just go with it. So what I get on this one is 1 point, and we're going to the nearest tenths again. So it's actually 1.02. So that would be our answer. And this is an approximation. We are putting in 10, so I guess we would just put the number 1 in here. And that makes sense. These are really small sides. This one, comparatively, very small. So here we go on this next one. We have triangle TUV. V is my smallest angle. It's about 36 degrees, so I'm going to put that one there. 71 is this medium size angle. That's the U value. So we got to figure out what that other angle is. So I'm going to subtract 71 and 36 from 180. And this is a 73 degree angle. And then the only side I have is side T. And T is going to be opposite of angle T. So this is side T, so that is 6.6. Again, the only opposite combination I have here is the T's. So we are going to set up 6.6 over sine 73 equals, well, we're looking for U, so we have to use angle U, sine. U is 71. To our cross multiplying. Hopefully you're learning this process pretty uniform on this little process here. So this is U sine 73 So we're going to divide by sine 73. And this will give us our u value. So I'm going to take this to my calculator. Alpha F1, 6.6 sine 71 divided by sine 73. So I get an answer of 6.52, so that doesn't round up, but it did round, so we need to make sure this is an approximation sign. And this makes really good sense. The 73-degree angle was 6.6, the 71 angle is 6.5. I feel really good about this answer. And the last one we're going to take a look at. Triangle LMN. Well, L is the tiny little thing, 11 degrees, so we'll put L here. It is 11 degrees. N, 46 degrees. Let's see what's left of our 180 degrees when we take those two away. My figure is not drawn to scale at all here, but that's okay. So this is 123 degrees. Now the figure doesn't have to look good. I'd like for it to, just because I can make a visual assessment of things, but it's okay. So on this one, we obviously have to use n because n is the only combination of angles and sides that we have. So we're going to take the 92 over sine of 46 and set it equal to, we're looking for side L here. Forgot to label this one. So side L would be this side right here. So we have to use the 11 degree. And we should know that 11 degrees is really small. So this side should also be very small. So we cross multiply. 92 sine 11 equals L sine 46. And then we are going to divide both sides by sine 46. Setting it up in that fraction mode again. And we get L equal to 24.4. It says round to the nearest inch, so L is just going to be 24. So you have the rest of this Delta Math assignment to work on. Good luck.